In Chapter 3, Part 1, Chemical Reactions, we're going to talk about what is a chemical reaction, what aspects are important for a chemical reaction, and what are we looking for in a chemical equation. So a chemical reaction tells us about how chemicals interact with one another. So what does that mean for them to interact? So an equation could be something as simple as A plus B gives us C. So where we can see that 1 mole of A or 1A combines with 1B to make C. So the stoichiometric ratio is something where we think about 2 A molecules plus 3 C molecules gives us 2 B molecules. So stoichiometric ratios are in fact these big numbers here at the top. It tells us about the ratio that these interact with one another. It tells us that we need 2 A's. So we need this plus these 3 C's gives us B's. And so in this case, we can look at the stoichiometric ratio for all of these and we can start to calculate that. The other thing that we know about equations or these reactions are the parts of the equation. And so what we can see is that on this side are our starting materials. Otherwise known as reactants. And this over here is our ending material. And in chemistry, we tend to think of that as the products. And so this arrow up here basically tells you that a reaction is happening. And so you can say that 2 A's plus 3 C's reacts to form 2 B's. So chemical formulas and chemical states are part of the information that we can think about in this case. So when we think about our chemical equation, if we were to have 2H2 plus O2 gives us 2H2O. Over here, this is our stoichiometric ratio. Or the stoichiometric coefficient is probably a more exact term. But then the other number that we need to talk about is this down here. So our subscript is about the identity of the molecule. So we can change the stoichiometric numbers. We can't change the subscript. So you could make changes to values that are found here when we balance equations. We don't balance equations by changing the subscripts. So it's important that we know how to identify compounds, or as we'll learn in later chapters, how to predict what the products will be. Right now, we don't necessarily know that. So the other thing that we need to think about are the chemical states. So chemical states tell us what we can find in nature. So we tend to see things like a tiny s for solid, an L for liquid, a G for gas. In Gen Chem 1, we're actually going to see a lot of AQ, which means aqueous, which is super fancy chemistry speak for dissolved in water. The only other symbol that we're going to see occasionally is actually this triangle, which means we added heat. So for an example, if we had something that went A goes to B, in this case it would say A with heat made B. So you could think about that could be cookie dough, with heat gives us cookies. So it just means that it's heated. Typically, we tend to think that it is hot at a very high temperature, so not necessarily the temperature that cookies are made, but that's what we tend to see. So in Gen Chem 1, we're going to encounter 4 different reaction types. We're going to learn about 3 of them today. So there are 3 different types: combination, decomposition, and combustion. So a combination reaction is 2 or more substances combining to form one product. What does that mean? A plus B gives us C. That's a combination. So an example might be something where we have 2 magnesium solid plus O2 gas gives us 2 magnesium oxide solid. So this tells us that we need 2 magnesium plus 1 oxygen, but that oxygen comes as a pair, right? So oxygen gas is a diatomic, and so there are several diatomics that we'll encounter in lots of these questions or problems. And so the other thing is this creates 2 magnesium oxides. Now, right now, we'll be able to read this out of words, so you could read it in words and then transcribe it into chemical formulas. Later on, we will talk about how you could predict a product. But for combination and decomposition, the products are somewhat hard to predict. So the second is a decomposition, where one substance decomposes to form 2 or more products. And so this also usually happens with heat. So if we have a substance D decomposes when you heat it up to make E plus F. So in this case, our single product or our single reactant, when you add heat, is going to create 2 products. So in this case, one example would be nitrogen gas. No, it wouldn't. Sorry about that. So in this case, we would have calcium carbonate solid. When we superheat that or heat it up, we'll get calcium oxide plus, which is a solid, plus CO2 gas. So one thing you'll notice is I'm including states in all of these, and they're all balanced. So as we move forward through chapter 3, we want to make sure that we are keeping track of our states and whether or not our equations need to be balanced. So the last type of reaction we're really going to talk about in chapter 3 is a combustion reaction. This is the combustion, or we're going to use fire for this one, the combustion of a substance with oxygen to create CO2 and water. So overall, a combustion reaction is pretty simple. We will have one component, so we will have something, which I'm going to create as X, plus O2 gives us H2O plus CO2. In this case, we're going to have gases as all of our products. Oftentimes, you will also see that water is created as liquid water, but you can use either one. And so the state here would be determined by the product, by the question. So one example of that would be the combustion of propane, which is C3H8. In this case, it's a gas, plus 5O2 gas gives us 3 CO2 gas plus 4 H2O gas. So there are 3 types of reactions that we're going to encounter in this chapter: combustion, decomposition, and combination. So let's think about how would we write the balanced chemical equations for these. So you'll notice that all of these tell us what the states are and what the products are. So in this case, we want to use the skills that we learned in chapter 2 with naming. So the first thing we want to look at is this first example, where lithium metal plus fluorine gas combine to form solid lithium fluoride. So we know that we're going to have lithium, solid, because that's a metal, plus fluorine gas. And so fluorine is also a diatomic. So the diatomics are elements that are halogens as well as nitrogen and oxygen gas. So those 7 or 8 compounds are diatomics, and we do need to know that. So these combine to form lithium fluoride, which is a solid. And so we know that lithium and fluoride combine in a 1-to-1 ratio based on the charges. So when we look at this, we need to observe that this equation is not balanced. What that means is there's 2 fluorine atoms on the left and 1 on the right. So we can go back and put a 2 here, and that gives us 2 fluorine on both sides, and a 2 here as well. The next video will go in depth on how to balance chemical equations. So solid barium carbonate decomposes into solid barium oxide and carbon dioxide gas. So barium carbonate, so barium is Ba, and carbonate is CO3, solid. Carbonate, remember, is one of our polyatomics, and so carbonate is CO3 2-, and it's going to decompose with heat into barium oxide, which is a solid, plus CO2 gas. And then you should double check. So there's 1 barium on both sides, 1 carbon, and 3 oxygens. So this equation is in fact balanced. So the next one is a combustion reaction of liquid methanol, but it doesn't give you any of the products or the other reactants. That's because they're always the same. In Gen Chem 1, we are mostly going to encounter combustion of alkane molecules and alcohols that you learned about in chapter 2. And so the combustion reaction of liquid methanol would look something like this. So methanol is CH3OH, liquid, plus O2, gas, gives us CO2, gas, plus H2O, gas. And then this equation will need to be balanced. And so we can go in and look at that. And what we'll find is that there's 2 methanols for every 3 oxygens, creating 2 CO2 and 4 Yahtzees, H2O. So that would be a balanced chemical equation. And don't forget, the next video will cover how to create balanced equations.